Hello everyone, welcome to Code for Teachers. I'm Michael Taggart and this is Chapter 6, Objects. And in this first video of the chapter we're going to be just introducing objects in general. Now, so far in our programming we've used basic expressions, conditionals, loops, and we've covered functions, which I've explained is kind of the building blocks of really complex programs. So you might think, well, wait a minute, what are objects and why are they so important if we have functions? We'll get to that in a moment. Our lesson objectives for this chapter will be thinking and coding in objects and glimpsing the power of thinking in object-oriented programming, or OOP. And then this is going to be a lot of fun, actually, because of the way that object-oriented programming is structured. For both you and your students, it's going to be a lot easier to write these programs, I think, than other structures, including functions in some cases. So let's talk about objects. Now, when humans think about the world, we think of it as a composite of objects and their interactions, right? The way that you interpret the universe is through the things that surround you and what they do and what they are and how they behave, what they look like. I went to the store as a sentence. The rocket is fast. These sentences describe objects as either an interaction or a state or both, but importantly, objects are the core of what's going on in these expressions. Now, computers don't think, they just process information. And it's important that we always remember that they're not doing any independent cogitation, right? They're just processing the information that we provide. But with object-oriented programming, we have a way of structuring that information that makes sense to humans. So it feels more natural to write certain programs in an object-oriented way because we mentally contain information inside of objects. So when we create objects in a computer program, the objects themselves are manifestations of what are called classes. And classes are just blueprints for individual objects. So for example, any given chair that you have in your surroundings, in your classroom or in your office or at home, that chair would be an instance of the chair class, right? It has some basic attributes the same as other chairs that you would find. So we create the class for an object first, and then when we need a new instance of that object, we call that class and create that new individual object. Now when we do that, what we're doing is we're invoking the class's constructor function. So classes have functions built into them. What constructors do is they take the information you give the constructor to make that object individual, unique, and with those general universal characteristics creates a new instance of an object and returns it. Every programming language uses different syntax to create new objects if they have object-oriented programming. In Python, the constructor looks like this double underscore init double underscore function. By the way, sometimes we call the double underscores dunders. So if you hear me say dunders, that's what I'm talking about, these double underscores here. And that init function is going to be the constructor. So that's what happens when we ask for a new car. A couple of other vocabulary points just before we jump into the code. You'll hear me talk about properties and methods. Properties are things that an object is, its characteristics, and those are built into the object, as we'll see. And methods are an object's abilities, what the thing can do. I like using cars as an example. They're great as a class example because all cars have the same attributes. In addition to four wheels, which we don't need to define, every car has a year that it was made, it has a make or a manufacturer, and it has a model name, right? 1997 Ford Taurus or whatever. Those are things that we can universally say about cars. So to create individual cars, we can create a class that contains that information and can produce individuals. All cars can also do the same things. They can accelerate, decelerate. That's the basics of what they can do. They can also turn. So because there's so much similarity amongst cars, we can define a useful class to contain that information. Let's jump into the code now and create a car class in Python. Okay, so here I am in Visual Studio Code, and I'm in car.py, and you'll notice a couple of things that I'm doing here different from previous videos. I have what are called doc strings, which are these comments up at the top and underneath the class and inside the init function. The most stylistically appropriate Python has these doc strings, which are just multi-line comments. Even if they're single lines, we use the multi-line comment delimiters to define what we're doing. So we're documenting our classes here. And the reason we do that is because there are automated systems that will run through your code, and if it's commented correctly like this, it'll produce automatic documentation for you. That's incredibly helpful as your programs get more and more complicated. We won't need to cover that here, but just know that it's good practice to put these doc strings right underneath any new class or function or module that you're building. What is a module? So a module in this case would just be the Python file itself, the car.py. So let's see what we have here. We have class car and then a colon. And then we have def, so we know there's a function. And then there's our dunder, init, dunder. And then what are the arguments that init takes? Well, we'll get to that in a moment. Self, year, make, and model. You might notice something else different from previous videos, that this year has a colon and int after it. It has make has a colon and then string after it. And then model has a colon and string after it. In Python 3.6, which is what we're using here, we have the ability to do what's called type hints. And that means that when we're creating a variable or we're defining arguments to a function, we can use this colon and then the data type syntax to tell us what kind of data type that argument's supposed to be. Now, you don't have to use these. You can just remove the colon and int components or colon and string from all these. But I actually think it's a good habit to get into to use these type hints because it helps us think about what we should expect to come into functions and to go out of functions. Okay, so this init is the car constructor function, and right now it's not implemented. This pass just means do nothing. But let's implement it. So you'll notice that the first argument to the init function, the constructor, is self. And self, think of it as the individual car object that's about to be constructed. So the car class has this constructor function and it's about to build this new object. And so that new object, kind of in an embryonic stage, gets passed into the init function. So we can use self to define some things correctly. So we know that the car is going to have a year, it's going to have a make, and it's going to have a model. How do we attach those things to the new car that we're building? So we actually use self. We say self.year equals year, and what that's saying is that for this new object, this new car we're making, we want its year set equal to the year that we're passing into the constructor function. And we do the same thing for self.make equals make and self.model equals model. Okay, let's leave that for now and let's go ahead and make a brand new car just outside here. So let's try Mustang. So we'll say Mustang, and again I can do this type hint, car equals, and then how do we make a new object? We are going to call the class car as though it were a function, and what that's going to do is it's going to invoke the constructor. So you'll notice that VS Code very helpfully is asking me to put in a year. I like the 1967 Mustang. So 1967, put a comma in there, says I want make, Ford, and then model, Mustang. Okay. Now again, if you didn't want to use type hints, that's perfectly acceptable. That works just fine. But I'm going to be a little bit pedantic about it here and use type hints because I like the clarity that it gives our code. Okay, now let's also have this program print out the car's year, make, and model. So Mustang.year, Mustang.make, Mustang.model. Okay. And then we're going to go and get our integrated terminal and then get into the chapter 6 folder here. Cool. And I'm going to run Python car.py. And sure enough, it prints out 1967 Ford Mustang. Now, this is a little bit tedious, and I don't want to have to do this every time. I don't want to have to make this combination of Mustang.year, Mustang.make, Mustang.model. So I'm going to make another car method. It's actually really useful, and we'll probably end up using it a lot in our code. There's a built-in function called dunder str dunder, so like this stuff. Str. And that takes self as an argument. And what this does is this teaches the car class how to represent itself as a string. And so this function actually does have to return something. And so we could say return, convert the year to a string because the year is an int. Self.year plus self.make plus some spaces plus self.model. And now, with this function defined, I don't actually have to do this print Mustang.year plus Mustang.model. All I have to do is say print Mustang. And it prints out the same thing, but because I've taught the car how to represent itself as a string, then I don't really need to worry about that extra conversion. That's a pretty useful built-in method for objects that we can use. As you can see, adding methods to objects makes working with information easy. We've got our magic string function that tells Python how to print the object. And just remember that every time we print anything, what we're actually doing is asking Python to call an object's built-in underscore string underscore method, even when we're asking it to print an integer or simple primitives like that. There's a built-in dunder string dunder because everything in Python is an object. Now, these are basic, but what if the cars had acceleration and top speed properties? What if we had methods about accelerate, decelerate, things like that? The more we add to the cars, the more realistic we make this data model, the more things we could do with them. And without too much work, we could actually create a simulated race of two different cars. Since we can make more than one instance of a car class, we can create a race. And in the next video, we're going to do exactly that. All right, that's it for this section. I hope you've enjoyed making your first object-oriented program. In the next video, we are going to put this together with a race class, and we are going to race some simulated cars. I'm Michael Taggart. Thank you for watching Code for Teachers.